Today we're talking about polynomial functions. You guys will be learning how to find roots, factors, and more of polynomial functions. Some of this will be reviewed from pre-calculus because that should have been where you were first exposed to, finding roots and factors and graphing those different types of functions. And so we're going to be refreshing memory on that, doing operations. That's like goes back to like algebra 1, but then of course taking it, to the next level. Okay, so there we go. A polynomial function, as you guys should know, remember it is in the form of what you see below. Okay, that is the general form of what a polynomial function is. Okay, x plus 3 is an example of a polynomial function, just has a special type of name. X squared plus 2x plus 3, that's another type of polynomial function. Okay, what you see in that blue box pretty much is that general form. Okay, a sub n x to the n plus a sub n minus 1 x to the n minus 1, and so on and so forth until you get to a squared x squared, or a sub 2x squared plus a sub 1x plus a sub 0. All that can be shortened by saying the sum as r equals 0 all the way up to n of a sub r x to the r, where a sub 0, a sub 1, all the way to a sub n are constants. And of course, a sub n cannot equal 0. All right? Now again, x is considered your what? Your unknown value, okay? AKA, what other word means that? Variable. Your variable, okay? X is your unknown value. It is your variable, okay? And if you think about all of the different polynomial equations, every single one of them has an unknown, right? That's a variable. A sub 0. If you look at this long general expression, a sub 0 is right here. It is the constant, yes, okay? That term that does not have a variable, does not have an unknown, that is known as your constant, okay? What about a sub n? What does that represent? Where is it located? A sub n is located right here in the front of all this madness. It is your leading coefficient. It is that coefficient that is attached to that unknown raised to that power, and all the other powers after that are going to decrease. Okay? Now, if you look at the condensed form of that polynomial expression, a sub r is what? What would a sub r represent?
It's still your leading coefficient.
Say what?
It's still your leading coefficient.
But if r is, other numbers going from 0 all the way up to, let's just say 5 or something like that, will it always be the leading coefficient? But a sub r will always be the what?
The first term.
No, not the first term. Remember, this is condensing all of this. And if a sub r is attached to the x raised to the r power, then a sub r, okay?
Is that the product of all the coefficients?
No, not the product of all the coefficients. It is just the coefficient. It is just the coefficient. If you want to be more specific, it's the coefficient of a particular unknown raised to one of the variables. So either being raised to the first power or to the second power or to the third power, depending on what r is. What about n? What does n represent?
The starting power.
And starting power, yes, that has a more mathematical name.
No, it was like
Degree.
Say again.
Degree.
It is the degree.
Oh.
Very good. Yes, that is the degree. Hence why it's also at the top. It's the largest exponent that you're going to have. Okay, your degree is always the largest exponent. And then lastly, that a sub r x to the r
Sure.
is what?
I was just pronouncing it.
Oh. What is that? So what? Could it be? So like r was 1, r was 2, r was 3, r was 4. It's what?
the general form.
No, that's general form. Like I'm just writing out terms until maybe someone says it to represent what a sub r x to the r is.
Term. Straight up term.
It is.
What?
like when I said it, I was like, crap, I gave it away. It is the term.
Bro.
It's the term of the polynomial. Because look at what I'm doing here. Okay? Look at what I'm doing as I'm writing these out. Okay? First off, I started. Well, I didn't start at 0. I should have started at 0. Okay? If I start at 0, it's the sum, so I add from 0 to some power. You know, I just keep going until I can't go anymore, and then I get to like the general expressions. But basically, that a sub r x to the r power basically represents each term of the polynomial. Okay? And if I start at 0, this is when r is equal to 0. The next one will be 1. The next one after that, 2, 3, 4, 5, all the way up to n. N would be that largest exponent. The largest exponent, which represents the degree. Okay? Questions? Now, like I said, you guys have dealt with polynomials before. Okay? Different ones have certain special names. Okay? Like that very first one. Ax plus b, when a does not equal 0, has a degree of what? It has a degree of 1. Any 1-degree polynomials, they're not called 1-degree polynomials. They're called what? They're called linear. Okay? They're called linear functions. Not polynomial, 1-degree polynomial functions. No, they're called linear.
First degree.
Okay? Or first degree. What's the degree of the next one? And those are called what? Not 5. They're called quadratics. Because remember, they have special names, okay? What about the next one? What's the degree? 3 is the largest exponent. A third degree polynomial is called a cubic. And the last one is degree of. And those are called
Quadratic.
no, that's 2.
Square.
No. If you think in that realm, 4-sided figure is called a quadrilateral, but the quad part is already taken for its second one. So what's another word that represents 4? No.
Travel.
Let me see. Something to get y'all there. $1. When you think of $1, and you break it down to its change, which change will give you
Quadratic.
Yeah.
Quadratic.
Quartic. Not a quartic.
Okay?
No.
After 4, I mean, there's 5 too. 5 is a quintic, but it's usually after 4, it's just a polynomial from that point.
Septic.
It's just a polynomial from that point. Okay?
Octic.
Quadratic.
So, a little bit of background to refresh your memory. Okay? Operations of polynomials. This is old. You've been doing this since Algebra 1. Remember, when you're adding polynomials, you combine like terms, you collect like terms. Okay? When you multiply, there's 2 different types of multiplication. You can either be multiplying by a scalar. What's a scalar? Another word for scalar.
This seems vaguely familiar.
Try me.
What's a scalar?
The thing outside the parentheses.
The thing outside the parentheses, like a number or a variable, right? This being that you would distribute over. Okay, you basically multiply each term by a scalar, so something like 2 parentheses.
A factor.
Okay, yes, like a factor. Okay, this would be your scalar. Okay, you'll multiply each term by that scalar when you're doing multiplication by a scalar. Or you can have 2 polynomials, or 3 or 4, and you basically when you multiply each term of one by each term of the other, and then simplifying. Okay, y'all remember that? All right. So then on your desk, show me.
Whoa.
Okay, I give you 2 polynomial functions, p of x and q of x, and I want you to what for a and what for b?
Subtract.
Very good. Do that on your desk. Sure, we're good. Ria, what you get for a?
3x cubed minus x squared plus 3x minus 16.
Very good. 3x cubed minus x squared plus, what'd you say, 3x?
3x minus 16.
Good stuff. And Callie, what about for b?
Negative x to the third minus 3x to the second minus 3x. Plus 3x plus 6.
Very good. Y'all get that?
Yep.
Okay. What about this? Jonathan, what you get for a?
3x to the 4th power minus 6x to the 3rd plus 12x plus 21.
Plus what?
Plus 21.
Stuff. And Jennifer, b.
Negative 2x to the 4th plus 4x to the 3rd minus 8x minus 14.
Yes? Good. What about this? So, when you multiply this, I know you guys have all your different methods and things like that. Let me show you something else that's kind of interesting. Okay? If you take the coefficients of each of the terms in both of the polynomials and multiply those, like doing like regular like old school multiplication, you can also get the coefficients of your polynomial. So if you take 1, 0, -2, and 4, and I put a 0 because if you notice there's no x squared term for p of x. And then if I take q, which is 2, 3, and -5, I basically treat them like numbers and I multiply them, and that will give me the coefficients of my polynomial. So that basically gives you, let's see, what's -5 times 4? So you have -20. Keep going. 10.
0.
And
-5.
-5. And you remember when you're doing multiplication, like the next number you go to, you skip this spot and you code it here?
Yeah.
Yeah? So 3 times 4?
12.
Keep going.
-6.
Keep going.
0, 3.
Good stuff. And then, so basically now you're here for the last number. Go.
8, -4, 0, 2.
Wow.
So you have -20, 22,
Wow.
2, -9, 3, and 2. Were those coefficients of your polynomial?
Wait. Oh no.
Okay, they should have been. Yeah, those should have been the coefficients of your polynomial. When you multiply x to the third times x to the second is x to the fifth. 5, 4, 3, 2, 1, 0. So 2x to the fifth plus 3x to the fourth minus 9x to the third plus 2x squared plus 22x minus 20. Is that the polynomial you guys got? Just want to show you guys this. I thought it was kind of interesting. You don't have to do it this way. You can do it the way you do it. I thought I'd share. Okay? Questions?
We'll talk to you about
I did that as a third instead of a square.
Yeah, that makes it different. All right. I don't know why my thing's delaying. This is really making me upset. All right. Let's talk about zeros, roots, and factors. Zeros, roots, and factors. First off, a zero. It is a value of the variable, which makes the polynomial. I started abbreviating from here on out, so when you see poly, I'm talking about polynomial. Polynomial equal to 0. Okay? A root is a solution to a polynomial equation, and the roots of p of x equals 0, so any polynomial function, when it equals 0, are the zeros of p of x and the x-intercepts of the graph of y equals p of x. So they all relate to each other, or they can relate to each other. Okay? So 0 is a value, so it's a number that when you plug it in, it makes the polynomial 0. A root is basically what you get once you solve a polynomial equation equal to 0. And then in correlation to a graph, it could potentially be the x-intercepts of that polynomial function. All right? So you don't have to write down what's in the black. I want to show you guys. You have a polynomial function. Therefore, p of 3, when you plug in 3, you get a solution of 0, which means that 3 is a 0 of the polynomial function. 3 is a root when you set that polynomial function equal to 0. And then the graph of that polynomial function has an x-intercept at 3. Okay? That's how it all relates. Think for a second. Will a 0 polynomial always correspond to an x-intercept of its graph? Now remember, always, just like those problems back like in geometry, always, sometimes, never. All you need is one instance to make that statement not true. Can you guys think of one instance of that not being true?
Don't you sometimes plug it in and you get no solution or something?
Not for a polynomial equation. For a polynomial equation, you'll always be like a solution. So every polynomial function, when you have a 0, it's going to be x-intercept.
if it looks like this, if it gets moved up, like 1 or 2.
Say if it looks like this, what if it gets moved up?
It won't be touching the x-axis then, will it?
No matter as much as I move this up, this will always touch.
No.
But
Can you have a hole?
not for a polynomial function, no. That's for a rational function. What other type of polynomial functions that you guys know about where this situation might not happen?
Linear.
No. Linear has the same thing. What you say, Logan?
Like a quadratic when it's like above or below.
Okay.
Imaginary numbers.
Something like x squared plus 1. Okay? Like if I asked you to find the zeros of this, what would you do?
You could.
Give up.
No.
Imaginary.
They're what?
Imaginary.
They're imaginary. You still would set it equal to 0 and solve this. It's still a 0. When you set a polynomial function equal to that number and you solve it, you're still getting a 0. But that doesn't mean that it's always going to correspond to an x-intercept, and this is one of those situations. Okay? So x squared equals -1. X equals what? What happens when you take the square root of -1?
It becomes imaginary.
It becomes imaginary, but it's not just I.
It's one eye.
It's not just one I. Thank you. It's plus or minus I. Okay? Come in pairs. All right. These will be your zeros, but the x-axis, those only occur for real x values, not imaginary ones. Okay? Polynomials can be written either in the factorized form or the expanded form, and that's what you see here. You have the factorized form of x plus 1, x minus 2, x minus 4. Then you have the expanded form, which is just by multiplying all three of those factors together. This right here is an example of linear factors. And you know that x minus alpha is a linear factor of a polynomial if and only if there exists a polynomial q such that p of x equals x minus alpha q of x. Okay? If you think back to a previous class, was there ever a time that you ended up having like x minus 1, and you'll have x squared plus 4x minus 3? Okay? So this right here is saying that if you have a linear factor, in this case it would be x minus 1 of the polynomial, if and only if there exists another type of polynomial equation such that together they make the original polynomial equation. Okay? That's what that's saying. So even if it's not fully factored, that x minus 1 is still a factor of the original polynomial. Do you understand? It doesn't always have to break down to individual linear factors to be for this to still be a linear factor. Okay? That's what I'm trying to say. Questions? I want you to do is I want you to find the zeros of these two. And just to make sure that everybody remembers how to do this, when you're finding the zeros of a polynomial function, what would I need to do to this polynomial function? I'll need to what? I need to factor it. Okay, well at least this one because it is a quadratic. Okay? If it doesn't factor, then what? Because I'm asking you to find the zeros. Not asking you to factor, I'm asking you to find the zeros. If it can't be factored, then what's the other option to find the zero? What a quadratic formula. Or the trig of completing the square. Okay? So go ahead and do these two, both of these. So, could I factor in A? So I had to use quadratic formula, completing the square.
Quadratic.
Formula?
Yeah.
Okay, so you have negative b plus or minus the square root of b squared minus 4a and c all over 2a. So that would be 4 plus or minus the square root of 16 minus
212.
all over 2. So you have 4 plus or minus the square root of negative 196. Is that a perfect square?
Yes.
Yes, it is. But it is a negative on the square root, so that means I need to have an I. So this
14.
4 plus or minus 14i all over 2. Did you leave it like this? No, because if there's a number like 4 over 2 or 6 over 3 or 8 over 4, you need to simplify that. Okay? So what does it simplify down to be? Yes. What is it? 2 plus or minus 7i. So my zeros are 2 plus 7i and 2 minus 7i. Over here for this other one, when I set this equal to 0, what did you do? Factor what? A z. Z is called the what?
The scalar.
It is the scalar. And the reason why it became a scalar is because it was the what of that polynomial? The common factor. Okay? Greatest common factor. So that left us with this. What did you do from here?
Use the quadratic formula on the polynomial.
Yes, you could definitely do that with the inside. However, I would use zero product property and set both of these factors equal to 0 because I am looking for the zeros. Okay? There's one of them. The other one was plus or minus the square root of 3i. Where was your I? Should be on the outside. So I square root of 3. Make sure your I's in front. Okay? There we go. Questions? Here we go. Factor. Both of these. At least A for sure. I'm curious to see if anybody gets B. Factor. Hopefully you recognize that A had A, GCF. You factored that out? So you had 2x squared plus 5x minus 3, yeah? The inside could it be factored? You guys get that? So, now this one, there are no two numbers that multiply to give you 9 that add together to give you 4, correct? All right. You would be doing the quadratic formula because it just asks you to factor. As long as you have your zeros, you can write your zeros as factors, right? So, when you do quadratic formula, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. Is that right? So then you have negative 4 plus or minus the square root of negative 20 all over 2. Does the square root of 20 simplify? Well, it's negative, so I definitely need to pull out an as well as a 4. Square root of 4 is, so it'd be 2i. Square root of 5 all over 2. Does this simplify? Sure does. To negative 2 plus or minus I root 5, correct? So those are my two zeros. Then that means that I'll have negative 2 plus I square root of 5, and then negative 2 minus I square root of 5 as my zeros. And because they're zeros, they can be written as factors. You would need to put them in their factor form. Okay? Think about it. Over here, if x was equal to negative 3, that meant that you had to put it, if you put it back in the factor, you basically change the sign and you have x plus 3, because technically you set this equal to 0, solve, and that's how you get your 0. It's the same thing, you just need to put it back into its factored form. So take the 0, change the sign, and you have your factor. Take the 0, change the sign, and you have your factor. You can either leave it like that, or you can distribute the negative through to get your full factors. So that would be x plus 2 minus I square root of 5. X plus 2 plus I square root of 5. There you go. Questions? So keep it moving. Okay? We're going to find all real cubic polynomials with zeros of 1/2 and negative 3 plus or minus 2i. Okay? You guys did something similar to this back in pre-cal when you were asked to write a polynomial function when you're given the zeros. The only difference between this and what you did in the past is the word all. Okay? But we still go through it. No. Retract that entire thing. I was going to say we still go through it the same way, and I was like, no, we don't. I apologize. Okay. So, go ahead and get this down in your notes. We're going to write all real cubic polynomial with those 3 zeros. So, we know that if I have 2 zeros, and I wrote them in their factors, and I multiplied them together, that would give me a what? Just 2 zeros. When I multiply 2 zeros together in their factored form, that would give me what type of polynomial? It give me a quadratic. And if you think back to what we talked about when we did quadratics, the whole sum of 2 zeros and product of 2 zeros, you guys remember that? What was the rule? That if you added the 2 zeros, it equaled what? Who remembers?
Add the 2 zeros.
Mm-hmm.
Oh goodness.
Which one was it?
I have them.
And this one? And that's C over A, okay? So what we can do is we can take these two imaginary zeros, because you want to work with your imaginary parts first and then incorporate your real, okay? So if I take the two zeros, which are negative 3 plus 2i and negative 3 minus 2i, and I add them, okay? What do I get? I get negative 6. And then when I multiply the two zeros, can you guys multiply them real quick and tell me what I get? Positive or negative? Positive? Yeah, I didn't know if you said positive or negative 13. So since we know that negative 6 is equal to negative b over a and 13 is equal to c over a, we kind of know what our quadratic is. Okay? What's the value of a? Say again. 1. Value of b? 6. And then c. So you have x squared plus 6x plus 13. Okay? And then since we have a 0 of 1/2, which is a real 0, we can write that as a factor as well. How would I write 1/2 as a factor? X minus 1/2 or 2x, not plus 1, but minus 1. Very good. Okay, because remember, that's like just saying x equals 1/2. Before it, yes, it would have been x minus 1/2. But remember, bottoms up, you can bring that bottom right on up, and then you have that. Okay? And so then from there, since you're trying to find all your real cubic polynomial functions, this right here will give you just one. So to find all of them, the only thing that could really alter this would be any type of coefficient in the front. And that is your polynomial function.
Oh, this.
Okay?
That's my major.
Can you guys do this one for me?